a soft precision Viterbi decoder for 1 by 2 rate convolution codes. My name is Harsha. Going to the overview of this presentation, I will first give an introduction to the domain and about the paper that I have written, and then a detail about convolution coding and Viterbi decoder, and followed by the program overview which I have written in MATLAB and a short section on results. To introduce this system, we are talking about finite state based systems. So the convolution coder and the Viterbi decoder both are finite state machines, and this gives them particular advantages like implementation on hardware. Viterbi decoder is a maximum likelihood decoder in the sense that it uses the best branch metric to take the decision, and this is a greedy algorithm by which it gives the best results. There are two types of uh, decoders. One is the hard decision and the other is soft decision. More of about it in the next slides. First, talking about the convolution coding. So convolution coder is a error connecting code, meaning that it follows certain patterns by which the decoder at the decoder, if we have the same polynomials, we can correct any errors that occur. A convolution code can be recursive or non-recursive. A recursive code is one in which the output is given back to the input, and then the next subsequent outputs are generated. A non-recursive one, the output is directly generated from one input. It can also be systematic or non-systematic, meaning that the input is directly given to the output in at least one of the outputs. In this case of this project, I have implemented a non-recursive non-systematic code. The convolution code is represented by m by n code with x5 generator polynomial, meaning that the m by n is the data rate. For every m bits of input, there are n bits of output, followed by the generator code, which is this bit symbol by which the output is generated. In this case, we can see that output is generated for 101 followed by 011 for output 2. Going to the Viterbi decoder. Just one problem here. Now going to the Viterbi decoder, we have two types of decoder. One is hard decision, in which the Hamming distance is taken as the branch metric. The Hamming distance is computed between the received symbol and the alphabet or the receiver. The hard decision decoder considers only the received bit for computation of Hamming distance, and then hence there is lot of computation. However, it is very simple to implement. A soft decision Viterbi decoder takes in the probability of the transmitted symbol and the received symbol together, and hence it computes the Euclidean distance. In this case, the number of computations is very low because only two types of calculations are required. It is a maximum likelihood decoder, which means that both Hamming and Euclidean distance, only the maximum distance is considered for in the traceback unit in case of hardware. In hard decision and in soft decision, the maximum distance is considered to estimate which bit has been transmitted. Now going to the program overview, I have the program open here in a remote machine, and coming to the first thing, this is the Viterbi software. This is the Viter. It is implementing the soft decoder, and to start off, we have the reference table and the lookup table. Here we give the signal to noise, and this is the input sequence. Here we are calculating the intermediate inputs from the convolution codes. This is transmitted input. This is the convolution code. This is a final convolution code which is given to the this is a BPSK modulated signal, and noise is added to this at this point, where signal and noise are added together to form the additive white Gaussian noise. Followed by that, we have the path metric and the survivor path, which are used by the soft decoder to calculate the received symbol. Here we are calculating the Euclidean distance based on the path and the survivor path. And for every case, for the first two symbols, we have these set of rules, and for the remaining of the symbols, we have these set of rules to calculate the path metric and the survivor path. So as you can see, we have state 0 to 3, which means that this is a state machine, and the path is calculated based on certain rules which are mentioned in the references papers. Finally, at this point, we are we're calculating the output that is received based on the decisions of the maximum Euclidean distance, and this is within a loop which ends at this point. For every single bit that has been received, the output is displayed here. I will just run this program now. As you can see, the output and input have been input and output have been displayed here. So this is the input from this, and you can see that this input is same as the output here. Therefore, the Viterbi decoder and the convolution coder are working in synchronism. Next, there is this program which calculates the BR and displays it for us for calculation. I'm showing you the soft decision decoder in this case. On running the program, the program runs similarly, except that in the end, now we are having to calculate the simulation, the error rate, which is found here as the subtraction between the two. And this is shown in the graph here. So from the graph, we see that the BR is shown. I'm running lesser number of inputs because of time restrictions in the video recording. And now going to the hard. This is the hard decision demodulator. It is also very similar. The program is similar, except that the algorithm to decode is different now. And waiting for the results, we see that the hard decision decoder is here. Coming back to our slides, we saw that the hard and soft decision. Now we'll come to more result graphs. In this graph, you can see I have shown both soft decision and hard decision together. This is soft decision and this is hard decision. For any given BR, we can see that there's a difference of almost 2 dB between soft and hard. Thereby it shows that soft decision is much better than hard decision in terms of signal to noise ratio. And then this is for a very large input of soft decision decoder where 10 raised to 8 inputs have been given, and this it shows the graph here. You can see the difference in BR increases as we have more symbols. In conclusion, soft decision decoder has better performance and it has a better SNR for a given BR. It is a faster program because there are lesser computations as there is no traceback unit and there is lesser Euclidean distance computations. Implementing hard decision decoder is however easier. Thank you.